Okay. When dividing polynomials, dividing is the opposite of multiplying. To start with, we're going to be dividing polynomials by monomials, or by just one singular term. Is what we're going to start with. This is going to be basically the opposite of distributing. We're going to be finding the quotient of each term in the numerator. The numerator just means the top part of this fraction. And we're going to divide it by the denominator, so the bottom part. The denominator. When we're doing this, we need to remember to divide the coefficients. The coefficients are the numbers. Divide the coefficients and subtract the variable exponents. So when we're dividing things with exponents, we're going to be subtracting the top exponent minus the bottom exponent. We're going to make sure we write these in standard form. So we're going to put our answers in order. In standard form. With integer or simplified fraction coefficients. So our numbers in front of our terms should either be an integer or a simplified fraction. So for the first one, we have 18x plus 12x squared plus 2x cubed divided by 6x. What we're going to do is we're just going to go through and divide each term. Just like the opposite of distributing, where we multiply each term, here we're going to divide each term. So 18x divided by 6x, 12x squared divided by 6x, and 2x cubed divided by 6x. For the first one, 18x divided by 6x, 18 divided by 6 would be 3. And when you divide x by x, those actually cancel out. So we have just 3 for that term. So the next one, 12x squared divided by 6x. 12 divided by 6 is 2, so I'd have plus 2. And then x squared divided by x, we have 2 x's on top. We're going to cancel out one of them from the bottom, so we have 1x left. Then finally for 2x cubed divided by 6x, 2 divided by 6 would simplify to 1/3, so plus 1/3. X cubed divided by x, we have 3 x's on top, cancel one of them out, we're going to have x squared. So now we've divided each of these terms, I need to put them into standard form. The 1/3 x squared would go first, then plus 2x, and finally plus 3. And there is my final answer for this problem. It's the same thing for the next one. We're dividing 12n squared plus 9n minus 30n to the 5th, dividing them by 3n. So we have 12n squared divided by 3n, 9n divided by 3n, and negative 30n to the 5th divided by 3n. Going one by one, 12n squared divided by 3n would be 4n. 9n divided by 3n would be 3. And negative 30n to the 5th divided by 3n would be negative 10n to the 4th. But then we need to put those in order. The negative 10n to the 4th would go first. Then the plus 4n. And finally, the plus 3. So there is the final answer for that one. And we can keep going through. X cubed minus 16x squared plus 28x divided by 4x. We'd have x cubed divided by 4x. And then we'd have negative 16x squared divided by 4x. And then 28x divided by 4x. X cubed divided by 4x would give me 1/4 x squared. Negative 16x squared divided by 4x would give me negative 4x. And 28x divided by 4x would give me plus 7. And this one is already in order. X squared, then x, then the one that doesn't have x. So the last one that I'm going to do with you is this 10mn squared plus 5m squared n minus 30m cubed n to the 5th. So if we have 10m n squared divided by 10mn, then we have 5m squared n divided by 10mn, and finally negative 30m cubed n to the 5th divided by 10mn. Okay, one by one. 10 divided by 10 is 1. M divided by n would cancel out, and n cubed divided by n would give me n squared. So I'm going to have n squared. 5 divided by 10 would give me 1/2. M squared divided by m would give me m. And n divided by n would cancel out. And then finally, negative 30 divided by 10 would give me negative 3. M cubed divided by m would give me m squared. And n to the 5th divided by n would give me n to the 4th power. And again, need to put these in order. I'm going to need to zoom in so that I can fit it in the space. So this is going to be first the negative 3m squared n to the 4th plus n squared plus 1/2 m would be our answer here. So hopefully that will help you to fill in the rest of these.